Welcome back to the deep dive. This time, we're going to take a deep dive into interactive machine learning, or IML for short.
Okay.
And we've got this paper. It's called A Review of User Interface Design for Interactive Machine Learning.
Right.
And this paper, let me tell you, it's like a gold mine
Mm.
of insights into how to design interfaces that can, like, bridge the gap between human intelligence and machine learning. What do you think about that?
Yeah, I think it's spot on. I mean, the paper really drives home how important user interfaces are for any IML system. It's not just like you're peering into the system, it's like the entire foundation for that back and forth, that interactive learning process.
It is, it is. Okay, so before we go any further, I think it's important that we, get on the same page here.
Yeah.
What exactly is IML?
So IML is all about humans and algorithms kind of working together to build and refine these mathematical models. And unlike traditional machine learning, where you've got this pre-selected data and you just train the model in one go, IML is this constant back and forth. The user gives feedback, the model adjusts, and you keep going back and forth.
So it's like instead of just having, this one-shot training with this like static data set,
Right.
IML is more about this constant refinement loop,
Right.
and that's driven by the interaction with the user.
Exactly. Exactly. And I think where IML really shines is when you're dealing with these really complex concepts, these things that are just really difficult to define up front.
Uh-huh.
Imagine trying to build a model that can recognize, let's say, different architectural styles.
Oh, wow. Yeah.
It's really hard to try to capture all those nuances in a data set, right?
Right.
But with IML, you can have an architect, someone who really knows their stuff, actually guiding the model.
Yeah.
They can give feedback, help it learn those subtle differences, things a machine would never pick up on its own.
So it's almost like having this conversation with the model where like each interaction.
Right. Helps the model kind of get a little bit closer to understanding that concept you're trying to teach it.
Yeah. And the paper we're looking at, it really dives deep into these challenges, the design challenges of building interfaces for this kind of collaboration between humans and machines.
Yeah.
It's not easy.
Well, let's talk about those challenges then.
Yeah.
So the paper, it outlines these 4, what I would call key hurdles that make IML interface design really unique.
Okay.
So what's the first challenge? What do we have to overcome?
Well, the first one's pretty straightforward. Humans, we're not perfect.
Oh, really?
We make mistakes. We change our minds.
Yeah. I've been known to do that from time to time.
And all that inconsistency,
Yeah.
it can creep into the data that we feed the model.
Ah, yeah.
And this is what they call kind of formally imprecision and inconsistency.
Right.
And it makes it really difficult to guarantee that the training data you're using is actually clean and reliable. Yeah, it makes sense. I mean, human error can be a pretty big problem, especially when you're relying so heavily on user input.
Absolutely.
So what's the second challenge?
So the second challenge is all about bridging this gap, right? The gap between what the user intends and how the model actually interprets that.
Okay.
So a user might be trying to get across this really complex idea through their feedback, but the model just doesn't understand it in the same way.
So even if the data itself is precise, there can still be like a miscommunication.
Exactly.
It's like what the user means, what they're trying to get across, and what the model picks up.
Exactly.
Interesting. Okay, so what about the third challenge?
The third one's kind of interesting. It's that, in IML, you're dealing with a model. You're not dealing with just the static data set.
Right.
Models are dynamic.
Right.
They evolve, they change based on the feedback, and that can be really confusing for users.
Yeah, it's like the ground is constantly shifting underneath you.
Exactly.
So how do you even design an interface that can keep up with that?
That's one of the key things this paper tries to tackle.
Okay.
And then finally, you've got the challenge of what they call open-ended training.
Open-ended training.
It's kind of a unique problem to IML, unlike traditional programming where you've got this clear end goal. When do you stop training an IML model?
That's a good question.
Yeah.
How do you know when it's, quote unquote, good enough?
Exactly. It's a really interesting question, and it's an active area of research.
Yeah.
And the paper, it digs into a bunch of different approaches to try and address this.
Okay, so given all these challenges, then what are like the essential elements, the building blocks
Right.
of a well-designed IML interface? I mean, I know the paper kind of breaks it down into like 4 key components.
It does.
So what are those?
So the first one is what they call sample review. And this is basically how the system shows the user examples of what the model currently understands. It's like giving the user a peek into the model's brain to see what it's learned so far.
So the interface has to have some way to provide like concrete examples,
Yeah.
so the user can see how the model is applying those concepts it's been taught.
Yeah, exactly.
Okay. What's the second component?
So the second one is feedback assignment. And this is where the user actually gives feedback on how the model's doing, but it goes beyond just simple right or wrong.
Oh, okay. Can you give an example?
Sure. Let's say you're building a model to classify different types of trees.
Okay.
Now, instead of just saying, yep, you got that right, or nope, you got that wrong, you might actually be able to select specific features of that tree, like the shape of the leaves, the texture of the bark, things that really highlight what the model should be paying attention to.
So it's like this richer feedback so the model can pick up on more nuanced concepts.
Exactly.
Okay. What's the third element then?
So the third one is model inspection. And this is about giving the user tools, so they can really assess the overall quality of the model.
Okay.
It's not just about looking at individual predictions. It's trying to answer the question, how well does this model generalize to new data?
So it's about giving the user tools to understand how the model's doing overall.
Right.
And to kind of identify any potential weaknesses or biases.
Precisely.
Okay. Now, what about the fourth component? What's that all about?
The fourth one is the task overview. This is where the interface provides a high-level view of the whole IML process. So you can see your overall goals, the progress you've made, and any relevant metrics.
So the task overview is kind of like a roadmap.
Exactly.
It helps the user stay oriented, make informed decisions about the training process, especially when it comes to figuring out when to stop.
Exactly. Like you said, it's a roadmap that guides the user through the entire IML journey. So now that we've got a grasp on the basic elements of a good IML interface, let's kind of shift gears a little bit and look at the typical workflow in IML. The paper, it breaks down this process into 6 key stages. 6 stages that a user usually goes through when they're working with an IML system.
Okay, let's break it down then. Let's start with feature selection. How does that work, in an IML context?
Well, feature selection in IML, it can get pretty interesting. It's this real collaboration between the user and the algorithm.
Okay.
The user, they bring their expertise to the table, right? They can choose features they think are important, maybe speed up the training process, make the model a little easier to understand.
So you're not just throwing every single feature you can think of at the model. Sometimes it's better to be a little more picky.
Exactly. Sometimes less is more. Too many features can actually backfire on you, You get overfitting, the model doesn't generalize as well.
Makes sense.
Yeah.
Okay, so what about the next stage? Model selection. How much control should users have over that?
That's a really good question. It's kind of tricky, right? Can you trust non-experts to pick the right model for the job? Can they even compare different models and choose the one that performs the best?
Yeah.
It's this balancing act, You want to give users control, but you also got to make sure the model is actually doing what it's supposed to do.
It seems like there's a lot of room for error if the user picks the wrong model, right?
Yeah, there are definitely some challenges there, but there are also opportunities. If you can give users the right guidance, the right safeguards during this model selection process, you can empower them to make good decisions,
Yeah.
Without totally screwing things up.
So once you've got the model selected, you get to the heart of IML model steering. That's where this feedback loop really gets going.
Yeah, that's where the magic happens. The user looks at some sample outputs, they give feedback, the model adjusts, and so on. This dynamic interplay between human and machine, it's really fascinating to watch.
Mhm.
One of the big challenges here is something called concept drift.
Concept drift, what is that?
So concept drift happens when the underlying concept you're trying to model, it changes over time.
Okay.
Let's say you're building a model to catch spam emails.
Yeah.
Well, the way those spammers work, it's always changing.
Right.
So the model has to keep up with those changes.
So the model's got to adapt to these shifting patterns, essentially.
Exactly. And IML is actually really good at handling this concept drift because of that iterative nature we talked about. The user sees new examples, they give feedback, the model adjusts. It's a constant process of adaptation.
So it's like the user is this guide almost,
Mm.
kind of steering the model toward the target, even as the target moves around.
Exactly. And that brings us to the next stage, quality assessment. How does the user actually know if the model is good enough?
Yeah, that seems particularly tricky in IML. I mean, a lot of these tasks, they're pretty subjective, right?
They are. And the paper, it really emphasizes the need for evaluation methods that take into account the user's perspective.
Okay.
What are the actual goals of the task?
So it's not just about looking at the numbers. The user needs to be able to look at the output and decide, okay, is this actually what I wanted?
Exactly. And that ties into the next stage, termination assessment. When do you decide to stop training?
The age-old question, right?
Yeah. And in IML, finding the right stopping point, it's crucial. You got to avoid underfitting and overfitting.
Yeah, if you stop too early, you might miss out on some of the complexity of the concept. But if you train for too long, you might end up with a model that's too specific, too narrow. It won't generalize well.
Exactly. It's a tough balance, and the paper talks about a bunch of different approaches. You can monitor performance on a separate data set, use early stopping techniques, even incorporate feedback from the user.
So the decision of when to stop, it could be a combination of hard data and human judgment.
Exactly. And then we come to the final stage, transfer. This is all about taking that trained IML model and actually putting it to work in the real world.
This is where it all comes together, right?
Yeah.
How do you make sure that a model that's been trained in this interactive setting actually performs well out in the wild?
Yeah, that's a big question. And the paper, it stresses the importance of designing these IML systems with transferability in mind from the very beginning. You might use techniques like domain adaptation, where you fine-tune the model on data from the specific domain you're working in.
Okay.
Or you could use ensemble methods, where you combine multiple models that have been trained under different conditions.
So the goal is to make sure that these IML models, they can generalize beyond the data they were trained on.
Exactly. You want them to be robust, reliable, and ready to tackle real-world problems.
Now, after this whole journey through the IML workflow, the paper goes on to lay out 6 guiding principles for designing these IML interfaces. These guiding principles, they sound like a really useful set of guidelines for, well, anyone who's designing or using IML systems. What's the first one?
So the first principle is make task goals explicit. Basically, it means you got to be clear.
Okay.
Users need to know what they're trying to do with this system. They got to understand what they're aiming for, and what the limits are.
So setting clear expectations from the beginning and making sure the user has a well-defined goal in mind.
Exactly.
Okay, so what about the second principle?
The second principle is embrace uncertainty.
Embrace uncertainty.
Yeah. IML models, they're probabilistic, meaning they work with degrees of belief. It's not about absolute certainty.
Okay.
So the interface needs to reflect that. It's got to help users get comfortable with the fact that IML is about probabilities, confidence levels, not just black and white answers.
Yeah, that makes sense. I mean, a lot of people are used to systems that give them a definitive answer, a yes or a no.
Right, and that's not how IML works.
So the interface needs to help users understand that the model's output is more like a range of possibilities, not just one right answer.
Exactly.
Okay, what about the third principle then? What does that tell us?
The third principle is go beyond basic input. This
Yeah.
is about thinking outside the box, going beyond just simple clicks and drags.
Okay.
The IML interface should be able to capture the user's intent.
Uh-huh.
It's got to allow for richer forms of feedback, more nuanced interaction.
So instead of just saying right or wrong, the user can highlight specific things, point out patterns, things like that. Okay, what's the next principle?
The fourth principle is all about visualization. Master data representation, that's what they call it.
Okay.
You got to be able to show complex data, the model's behavior, in a way that makes sense to the user.
So finding the right way to visually represent all that, making it intuitive and easy to understand.
Exactly. If you can't see what the model's doing, how can you trust it?
Right. What about the fifth principle?
Fifth one is unleash the power of interactivity. This is where IML really shines, this back and forth between the user and the model.
Right.
The interface has to be responsive, dynamic, encouraging the user to explore, experiment, really take control of the process.
So it's not just about giving commands, it's about creating this sense of collaboration, this feeling that you're working with the model, not just telling it what to do.
Exactly.
Okay, so what about the last principle? What's the sixth one?
The sixth one is engage, engage, engage. IML should be enjoyable,
Right.
It should be rewarding. The interface, it should keep the user motivated, help them feel like they're actually contributing something valuable.
So it's not just about functionality. It's about creating an interface that's fun to use, engaging. It keeps people coming back for more.
Yeah, exactly. And these 6 principles, they really offer a solid framework for thinking about IML interface design. It's all about putting the user at the center of the process.
It is. It is. They really highlight how important user-centered design is in this whole field of IML, which is still emerging, still pretty new.
Yeah. definitely. Now, the paper doesn't stop there. It goes on to talk about some open research problems, some really exciting stuff that's shaping the future of IML. These are areas where user interface design and machine learning research, they really come together.
Okay, so what are some of these big research problems? What's on the horizon for IML?
Well, one of the big challenges is how to prime the user.
Prime the user. What does that mean?
It means how do we set users up for success right from the start, especially if they're not experts in machine learning?
So it's about creating this onboarding experience that's not intimidating. Make it easy for people to get started with IML, understand the basics.
Exactly. We need to think about intuitive tutorials, interactive demos, maybe some personalized guidance that takes into account the user's background and their goals.
Okay. What about the next big research problem?
So we talked about uncertainty before, but it's so important that it deserves its own category.
Okay.
Representing uncertainty, these probabilistic models, they're inherently uncertain. So how do we communicate that uncertainty to the user in a way that's clear and understandable?
Right. It's not enough to just show them a bunch of numbers. We need to explore different ways to represent those confidence levels, the probability distributions, the potential outcomes, maybe use more visuals, make it more interactive.
Exactly. We got to help users develop this intuition for what uncertainty really means and how it affects the model's predictions.
Okay, so what's the next research problem on the list?
The third one is immersive environments. This is where things start to get really interesting.
Okay, tell me more about that.
Imagine you could step into a virtual world where you can actually interact with data and models in a way that's completely intuitive. You could train a gesture recognition system by physically performing the gestures in VR. Or you could visualize a massive data set in 3D and manipulate it with your hands.
It sounds kind of like science fiction.
It does, but the potential is huge. These immersive environments could really change the way we think about IML, make it more engaging, accessible, and ultimately more powerful. Of course, there are challenges. You got to manage cognitive load, make sure the interactions feel natural, but it's definitely an exciting area of research.
Yeah, it is. I'm really curious to see what happens with that in the future.
No.
So what about the last research problem? What's the fourth one?
The fourth one is all about evaluation, evaluating IML interfaces. How do we actually know if an IML system is successful? Traditional metrics might not cut it.
Right.
We need new evaluation methods that consider the user's experience, How satisfied are they with the system? How much did they learn? How well did they perform the task?
It's a complex issue. And it requires us to rethink how we assess the value of these systems. It's not just about how well the model works in isolation. It's about how well the user can work with the model.
Exactly.
Well, this has been an incredible deep dive into the world of interactive machine learning. We've covered a lot of ground, starting with the fundamental principles of IML, and then looking ahead to the challenges and opportunities that are shaping the future of this field.
Yeah, we've really seen how IML is bridging the gap between human intelligence and machine learning.
It is. It is. It's like this fusion of human insight and computational power,
Right?
and it has the potential to change the way we solve problems and interact with data in a really profound way. So for our listeners, let's quickly recap the key takeaways from this deep dive. First, we defined IML and talked about what makes it unique, how user interaction is so central to the learning process. Then we dug into those 4 big challenges of designing IML interfaces: imprecision and inconsistency, the gap between input and intent, interacting with a model that's constantly evolving, and this whole issue of open-ended training.
Right. And then we went through the 4 essential elements of a good IML interface: sample review, feedback assignment, model inspection, and task overview. And we walked through that typical IML workflow, those 6 stages: feature selection, model steering, quality assessment, termination assessment, and finally, transfer.
And of course, we can't forget about those 6 guiding principles for IML design and those 4 open research problems that are really pushing the boundaries of this field.
Yeah, those are important too.
As a final thought, I think it's important to remember that IML is still in its early stages. It's rapidly evolving, and the research that we've talked about today, it just shows how much potential IML has. But it also highlights how crucial thoughtful design and ongoing research are. We need to make sure that these systems are truly effective, easy to use, and beneficial for everyone.
I completely agree.
So until next time, keep diving deep.